In this video we're continuing on with Unit 3 of National 5 Chemistry, and we're focusing specifically on plastics. Now, in terms of their chemistry, plastics are fascinating because they have many different properties that allow them to be used for lots of interesting purposes. But in National 5 we're going to really focus specifically on making plastics, or how certain plastics are made, and then how we name those plastics, depending on what reactant was used to make them. So the molecules in plastics are made essentially by joining up lots of small molecules called monomers. Remember, mono means one, or a single unit. And these make very long chains, often consistent of thousands of atoms linked together. And the large molecules which are formed from monomers are called polymers. So poly meaning many. And plastics are an example of these polymers. And when polymers join together, this is called a polymerization reaction, which we'll look at in a bit more detail at the end of the video. So for just now, we need to know these two terms, that monomers are these small single units, often quite simple compounds, which join together to create large chains called polymers. And you'll notice I've left two little linking open bonds at the end of my simple polymer diagram. I will come back to that in the video. So we're going to have a look at a few examples, and we'll start with arguably the simplest one. And the simplest monomer that we have is ethene. So why is this the simplest monomer? Because it has a key feature that monomers have to do this reaction that we're talking about to make a polymer. And that is being unsaturated. They have to have a carbon-to-carbon double bond. So, thinking of the families of compounds that we already know from National 5, our homologous series, the simplest alkene that we know, which is the family of unsaturated hydrogen and carbon compounds, the simplest is ethene, because we have to have at least two carbon atoms to have that carbon-to-carbon double bond. And so a polymer made of many ethene monomers joined together would simply be called polyethene, or polythene, which is maybe a word you've heard before. And that comes from the fact that, yes, we've used ethene monomers, and because there are lots of monomers reacting and joining together, they form a polymer, so we call it polyethene. So a polymer will always start with the word poly. And then whatever monomer was used, that's often the word that follows that poly part. So we want to now discuss how that actually happens, what that reaction is called, and how it works. So specifically, we want to focus on the idea of addition polymerization, which should ring a bell because we've already looked in National 5 at addition reactions which also involved double bonds. So it's very similar, except that there are lots of double bonds involved this time. So addition polymerization occurs between unsaturated monomers, monomers basically which contain at least one carbon-to-carbon double bond, and as we said before, we have lots of monomers joining to make a polymer. So in this case, ethene making polyethene or polythene. And when we want to think about this, when we want to draw this out and show it in detail, there's really three kind of key steps that we want to consider. So first thing is to take our monomer, whatever the atom is, well, not the atom, the compound, whatever the compound is, and in whatever form we usually draw it in, we want to make sure that for the purposes of this reaction and seeing exactly what happens, we draw it as what's called an H shape, which will hopefully make sense in a second. So we take our compound, and the way I've drawn it here is slightly different from how I drew it on the first page, but it's perhaps how you are used to drawing it. And what we want to do is focus on wherever the double bond is and have everything that is attached to those carbons drawn up and down, not to the left and right. And that will make sense in a second. So we pay close attention to what is joined onto this carbon here. We have a hydrogen at the top and a hydrogen which I'm going to move down to the bottom. Now notice I'm allowed to do that because I'm not actually changing what that hydrogen is bonded to. It's still just bonded to this carbon. I'm just sort of swinging it round without breaking the bond. Now if we look at the carbon on the right, exact same thing, it just contains a hydrogen up and a hydrogen down. Now, why are we wanting to do that? Well, what we want to do next is line up the double bonds in a row of these H shapes. And we always want to use 3 monomers to show how they are going to form a polymer. So if we draw them all out like this and just repeat the units, repeat the monomers, and add a little plus sign in between, we are showing that these monomers are going to react. They're going to add on to each other, which is why it's a form of addition reaction. And what happens is these double bonds, just like addition reactions we've looked at in the past, will open up, the double bond will break, and they will form single bonds with the other carbons of the other monomers. And this will go on and on and on, and there will be lots and lots of these monomers all joining together to make this very long polymer chain. So we're going to draw in what that looks like. So we have our carbon chain, in this case 6, because we're using 3 monomers which contain 2 carbons each. And what's happened is the double bond has broken, for example in this one on the left, and one of the carbons is joining to this carbon here, and the other carbon is joining on to another monomer that isn't shown. So we also want to show that. We want to show an open bond at either side of our polymer molecule to show that it continues on and on and on. Then all we do is draw in our H shape again. So this way we're showing exactly what is bonded to each carbon atom, which does not change. It's just as seen above. The only thing that has changed is the double bonds have broken and all the carbons have joined on to one another, leaving a single bond where there was once a double bond and a single bond where there was once no bond. So it's all saturated single bonds now. And that here is our addition polymer called polyethene. Now, not only do we know that this is polyethene, but we also want to consider what is called the repeating unit. So the part that shows itself again and again and again. So basically, if we zoom in to any part of this compound which was once a monomer, so for example, this part here, that is how I would draw the repeating unit. That's the part that I want to draw. So to show that it is repeating, I draw my H shape. I make sure it is a single bond in the middle, because if it was a double bond, it wouldn't be able to form any bonds to the left or right, because that would be too many bonds around the carbon. And then what we do is show those open bonds like that. And that shows that the polyethene is continuing to the left and the right, but this is the part that is repeated again and again and again. And that is the third step. So whilst this reaction is quite simple, because it's just compounds adding on to one another via a double bond, there's quite a few new terms and new ways to draw certain structures that we need to remember. So it's important to remember the difference between a monomer and a polymer. Monomer is the single unit that is used to make up our polymer, and the polymer is the big long chain. We need to remember to draw the monomers as H shapes. We need to remember how the double bonds break to form the singly bonded chain of carbons. And we also need to remember the differences between a monomer and a repeating unit. So a monomer has the double bond and nothing to the sides, because it exists on its own. And the repeating unit is a part of the polymer chain zoomed in, which used to be a monomer, but is now bonded in the chain, and is basically the piece of the puzzle that gets repeated and repeated, so could be anywhere in the chain. This could be near the end, it could be in the middle, and the way that we show that is with the single bond and the open bonds at the side. It is important to remember those open bonds, because if not, carbons wouldn't be bonded to 4 things. So to make this clear, we're going to have a look at a second example, and this time we're going to have a look at polystyrene and how that is made. So we're going to use the styrene monomer, which looks like this. So it has a carbon-to-carbon double bond and then a C6H5 part, which we won't bother drawing in National 5. But remember, our first step is this isn't a very useful form of this monomer to show how it's going to bond. So we have to draw it as an H shape. So if we do that just now, we're going to have our 2 carbons which have the double bond. That's the part we always focus on. And then we say, okay, what is bonded to this one? Well, we have an H at the top and an H at the bottom. And then what is bonded to this one? Well, we have, I'm going to draw the other way around. I have an H at the bottom and a C6H5 at the top. You can draw it either way. In this case, I'm just going to draw that part at the top. So that's me, I've got my H shape and it's ready to go. I can see how things are going to add to the left and to the right. And hopefully in your mind's eye, you can already see what the repeating unit is going to be too. So what we need to do now is line up, remember, 3 monomers, because that is how we do it. And I'm just going to draw in my final monomer now as an H shape, so you can see me do that again. So including all the atoms, all the bonds. And then we're going to show with an arrow what this changes into. So you can see that the double bonds have broken. They have formed single bonds with the carbons next to each other, and at either side of this diagram I've left open bonds to show that this molecule continues. It's very long. And you can hopefully see that every second carbon the cycle starts again. So CH, C, C6, H5, CH, C, C6, H5. It's the same thing again and again and again. And to show that, we're also going to include what our repeating unit would look like. So a repeating unit, remember, is set up very similarly to our monomer, except it's a single bond and it has open bonds at the side. And then we just choose, based on what our monomer was, a section that repeats again and again. So we have our H and our H, H and our C6, H5. And you'll notice that the order that they come in is basically the exact same as the monomer. Key differences being the monomer has the double bond and no open bonds, and the repeating unit has a single bond with open bonds at the side. And you may also be asked at National 5 to do this kind of process in reverse. So for example, you may be given a repeating unit and be expected to come up with what the monomer was that was used to make a polymer with that unit. Or you'll be given a polymer section like this, maybe even with more repeating units added on, and you will be expected to come up with what the monomer was in the first place. So be comfortable at going from monomer to polymer and from polymer to monomer. Just remembering all the key details about what each part is called, repeating units, monomers, polymers, and how to draw a monomer from what it looks like as it's given in a question to an H shape.